everyone. Today we are going to look at this problem, Asuna and the mosquitoes. This is from a very recent code forces around 2014 div 2. So the question says that Asuna has n admirers, right? So Asuna has n admirers and all of them have gifted her a tower. So the height of the tower from the ith admirer is equal to ai, right? So from the ith admirer, height of the tower is ai. So Asuna evaluates the beauty of the received gifts as max of a1, a2 till an. So the max of this is called the beauty, right? So she can perform the following operations. So there is an operation given. The operation is that we can take any I that is not equal to j, provided they belong from 1 to n inclusive, such that ai plus aj, first thing is it has to be odd. That's the first condition, and second is that ai is greater than 0. And then the operation is that we decrease ai by 1, we convert ai to a minus 1, and aj becomes aj plus 1, right? So now the question is that we need to maximize the beauty of the gifts. That is, we need to maximize this quantity, which is basically the maximum number that is present in the array has to be maximized. That's it. Okay, so now let's look at an example. Let's look at one of these test cases. The first test case is 539 and the answer is 9. The reason behind that is, let's say we try to increase 9. Okay, so we will find that 9 plus 3 is even, 9 plus 5 is even. So the problem is that as all the numbers in this particular array are odd, so we cannot really apply even one single operation, because ai plus aj module 2 is equal to 0 for all I and j, right? Similarly, if we had, let's say, 2, 4, 6, 8, the same problem would happen, and we would have to print the maximum, that is 8, as the beauty of the array. But then let's take a different example. Let's say 5, 4, 3, 2, 9. Okay, so from here we will begin explaining the greedy strategy behind solving this problem. So you can see that the tags given are also constructed algorithms, greedy and math, right? So we will find a greedy strategy. So see, the point is that we need to maximize the beauty of the array. So by that we can try to maximize the maximum element, which in this case is 9, right? So if you try to maximize this, can you observe one thing, that whichever the even numbers, right, we can directly add them, because always, if like for in this case as this is odd, so we can easily make 9 plus 4 plus 2 and we can get 15. So by that what we are trying is, we are making this 0 and adding 4 to this, we are making this 0 and adding 2 to this, right? So therefore we are adding, so this array becomes now 5 0 3 0 15. So now you must be wondering what to do, right? So the next idea is, what we can do, we can sacrifice one from this and one from this. So how are we going to do that is, so let's say from this 0, if you make this 0 1, okay, as 5 plus 0, this particular sum is always going to be odd, because this is an odd number added with 0 results in an odd number, that is basically the number itself. And we can make this 4, so we are basically sacrificing one point from here. Similarly we can do this, so we can make this 2 and make this 1, right? So we sacrificed 1 point here and 1 point here, right? So 2 and 4 both are even, so they can be again directly merged into this odd number, which is 15 plus 2 plus 4, which is 21, right? So from here you will get the basic idea of the problem. So the idea of the problem is, what you do is that you can easily add even numbers directly. If if the largest number is odd, then you can directly add the even numbers, right? And let's say if that is not the case, like, okay, let's take an arbitrary example. Let's take 10 4 3 2. So the idea is that you take 4, you take 2, and you take 10, you take 3. But see, what we can observe here is we can't directly add 4 and 2 to 10. So the odd number is 3, right? So let's add all the evens to this particular order, right? So then this becomes 3 plus 4 plus 2 plus 10. So in this case the answer is how much? It is 10, 2, that is 12, 16, 19, right? So what we can see is, and if you observe, this sum was 19 previously also. So first what we need is an odd number, right? We need a odd number, whatever it is. We will add all even numbers directly to this, right? And then we will get zeros in those places where the even numbers were present, and then we will sacrifice 1 and take that odd number, right? So basically it is odd number minus 1, right? So for every odd number we are adding the value of the odd number and we are losing 1 in value, right? So basically the point is, if you have k odd numbers in the array, one odd number is being used to manipulate all the even numbers, right? So basically we have k minus 1 odd numbers left, right? And for all those k minus 1 odd numbers, what we're doing is we're sacrificing one value, right? So therefore this becomes, if the sum of the array is s, right, let s be the sum of the array. So because s minus the whole sacrifice, so the whole sacrifice is k minus 1, that is 1 for each odd number we are sacrificing. So for k minus 1 odd numbers we will be sacrificing k minus 1. So this result becomes s minus k plus 1. Okay, so now the whole algorithm is basically nothing but that if there are only even numbers or only odd, then what we do is we will print the maximum whatever is present at this point, right? But if that is not the case, that is, if we have at least one even and one odd, and that could be even more, right? So if this is at least what we have, then the answer is s minus k plus 1, where k is the total number of odd numbers. K is the total number of odd numbers. So that is a very simple solution. Just need to find the sum, check how many odd numbers are there, which is going to be k. So the result is s minus k plus 1. So thank you for watching.